My name is Dr. Michael Atkin, and in this series we talk about emerging technologies, trending technologies with the experts right here at K-State Salina. So today my guest is Chad Bailey, who's an instructor in our robotics program. So Chad, thanks for being here with us today.
Definitely, no problem.
Tell us a little bit about the robotics program here at K-State Salina and kind of what you guys are doing, maybe projects that you get to work on.
Yeah, so basically we're looking at robots that are used in manufacturing or various production lines, things like that.
Okay. I know we have a little guy here. I'm guessing this might be kind of an example of, on a very, very small scale of what you might see in industrial robotics.
Yeah, so actually this is just kind of a little demonstration that we take out to schools with little kids. And
okay.
Growing up, I always wanted to have a robot arm like this. I thought they were so cool and just really wanted one. But what's kind of cool about this robot arm is that it gets kids interested in robotics, and it's really something that they can grow into later on in their career.
Maybe talk about all the different technologies that might go into creating a system like this.
When we talk about robotics, a lot of times we just think about the arms or the devices that move objects around. If you look at like an automation plant, like a automotive plant where you've got robots putting cars onto a conveyor, things like that.
Yeah.
But there's a lot of other equipment that goes along with it. And so automation is really all the equipment that runs the production line, all the sensors. We talk about the programmable logic controllers or PLCs, which actually are kind of the brains of the system.
Yeah.
So all those pieces really go into the robotics and automation side of things.
What goes into having a system like this work in like an industrial setting?
So basically with a robot arm like this, typically robots are very rigid and repetitive. Kind of the industry is moving more towards more flexibility, so flexible automation and machine learning. And so taking a robot like this, if you have different items, different products, maybe different sizes that are going down a conveyor line, it's very difficult to do that. So it takes a lot of downtime, maybe cost to modify fixtures. So flexible automation allows the process to really be, as it says, flexible. So
okay.
If your products vary, you can easily adapt to that.
So I'm guessing if there's like different sizes of parts and things like that, is that kind of what we're talking about? Okay.
Think about like a grocery store. Okay. So you're going through a grocery checkout and you take all your items out of the cart, you put it on the conveyor, and then you've got the cashier that's there. He's able to pick up those parts or those your groceries, scan them. But let's say you replace that cashier with a robot. All right. So I don't recommend that. I know it's very controversial.
Yeah.
But let's say you design that robot to pick up a can of soup.
Right.
Well, what happens if then you put a tomato on the conveyor?
Okay, yeah, I see. It could smash it.
Yeah, it's probably gonna be a mess, right?
Yeah.
Because you designed that gripper specifically for that metal can. It wasn't designed for soft fruits or vegetables, or even like ice cream cartons, things like that.
Right.
So flexible automation allows the robot to be designed to pick up multiple items.
I'm guessing that's kind of also where machine learning comes in, because it's got to understand, or maybe even probably things like computer vision, is it to kind of tell what the items are and then be able to adjust. Is that kind of explain, is that kind of how that works?
Right. So with machine vision, machine learning, we basically put in a data set of multiple images of how
Okay.
So let's say you take a carton of ice cream and you set it on a conveyor belt. It's probably not going to be in the exact position or rotation that you want. So taking those images of the milk carton or the ice cream in different orientations.
Yeah.
Training it how to pick up those items.
Right. Yeah. Kind of training the robot through machine learning and those libraries of images and things. Okay.
Yeah. So once you get that model trained, then if that carton of ice cream goes through in a different orientation, the robot's able to respond to that.
Yeah. Okay. So how would that, translate into maybe thinking kind of down the road, the future, this technology, like humanoid robots or anything like that with this? I'm guessing this is kind of where that comes into play with the machine learning. Is that correct?
Yeah. So you have like the AI machine learning side of things, and then you have the hardware, which is typically the robot itself. And then kind of the bridge between that is what we call that cyber physical system, where
Right.
you've got the AI and you've got the hardware.
Yeah, and it kind of all then works together. So, okay, cool. Well, this is cool stuff. I know, it sounds like students get to work on a lot of really cool projects. And so, just excited to see the future of this and where it goes. So thanks for being with us today.
Yep, anytime.
All right, so that's it for today. We'll catch you next time. Thanks.